Working at 35% of its full capacity, it can produce enough electricity for 50,000 homes. So what if it was working at full capacity? How many homes could it produce electricity for? In other words, what if it could produce 100% of its full capacity? Okay, that's what the question is asking for here. So what I would do is, I would write 35% is 50,000. Because this is a calculator, I'd perhaps then work out what 1% would be. Okay, that's one approach here. So you'd have to divide this by 35. Okay, so you divide 50,000 by 35. So I do that in my calculator. I get that, right? It's not a particularly nice number, but you get that. So 35% of its full capacity would produce enough electricity for 50,000 homes. If it was 1% of its capacity, it would produce enough electricity for 1,428.57 blah 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 homes. Okay, so you're dividing it by 35. Now we want 100%, so just times that answer by 100, and it would produce enough electricity for 1,428.57.1429 homes. Now, of course, homes, you know, we've got to think in terms of whole, yeah, amount of homes. Okay, you can't have a 0.14 of a home, so we could say here it would be 1,428.57. Okay, we round it down. Homes there. Okay. Now in next part, we've got to work out the mean, okay, and this will be an exact value for the mean because we've got exact value here, right? It's not grouped like the previous question, but it does say here in each of these 4 wind farms, if each of these 4 wind farms worked at the 45% of its full capacity, okay, what would be the mean power of a single wind turbine? So it's not these values you've got to take here, okay? We've got to do 45% of it, right? So what I'm going to do is, 45% is 0.45, times that by 2.0, or 2, and you get 9/10, 0.9. So in a sense, I'm going to sort of cross that off, and I'm going to ignore that. That's the power it's working at, right? Let's do the same then for the next one. And I get, okay, that's not particularly great, but that's what it is, 1.575. So the next one then 1.62, and the next one then 1.35. So we just got to appreciate now when we're working out the mean, okay, that we've got 30 wind turbines working at this power here. So it's 30 lots of 0.9, okay, and you've got 54 working at this power here, so 54 times that, and so on. So I can work my answers out by the side here. Okay, it's okay to work on the table. So I get 27 there, 85.05 there, 40.5 here, and 81 there. So when I work out the mean there, I've got to add these values up, and share by how many there in total. So I've got to add these up as well, right? So 30, add 54, add 25, add 80. No, it's 60, isn't it? Okay. Press equal, so I got 169 there. Okay, so that's what I'm going to divide by. So the top then becomes 233.55, divide them by 169, so I get 2 decimal places, 1.38, okay, so you don't have to put units, but it is megawatts, isn't it, so you can put MW if you want to, you don't need to though, so 1.38 megawatts.